can solve rational equations is our objective for this lesson. We want to talk about how we can take a rational expression that's now in an equation and solve it. The difficulty is because of the denominators, it can get in the way. So let me show you how we would do this. First of all, kind of formally, and then I'll teach you how to do it with the shortcut. So first of all, the first step here is in order to combine these two, I would get it with a common denominator. So all of these, if I put this over 1, the common denominator for this, so my least common denominator is going to be x times 2 times 1, and I don't need to put the 1 because that just leaves it as 2x. So what I'm going to do is create each of these with a common denominator. So I'm going to multiply this one by 2 over 2, this by x over x, and this by 2x over 2x. So I get on this one 8 over 2x plus x over 2x equals 2x over 2x. Now, I can combine this one together, make it 8 plus x over 2x equals 2x over 2x. So what I've got is two fractions that are equal to each other with the same denominator. It makes sense that if two fractions are equal to the same denominators, the numerators have to be equal to each other. So I'm going to have 8 plus x equal to that 2x. If I subtract x from both sides, I get 8 equal to x. Now what's critical here is that we recognize because this started out with fractions involved and there's a variable in the denominator, there are restrictions on that denominator. It involves the domain having restrictions. So we look at this one, we say that this one, the restriction on the denominator, is that x cannot equal 0 because that would be not allowed in that first fraction. So since this is not 0, we're okay. Our solution holds. Now let me teach you how we can do this using, it's just a shortcut that takes away some of this extra work. And so the way to do it is if we take this original problem, 4 over x plus 1/2 equals 1, if you take and multiply by that least common denominator on both sides of the equation, it speeds up the process a little bit. So what I'm going to do is I'm going to take the 2x times this side and 2x times this side. I'm going to distribute it to both of these. So 2x times 4 over x, the x's cancel, leaves me with 2 times 4 is 8. And again, the x's cancel, so no more denominator. That was the point of it. 2x times the 1/2, the 2's now cancel, and I'm left with x times 1 is just x. And then on this side, I get equal to 2x. Subtract x from both sides, you get 8 equal to x. So what we get is a little bit less work to have to put on the problem because we multiplied by the least common denominator on both sides. So here are the steps that we want to use to do these types of problems. We want to take, for the first step, we want to first of all multiply both sides by the LCD, the least common denominator. Okay, when we do that, we go ahead and multiply it through, reduce and simplify. The result of that should be that there's no more denominators. Okay, and then the third step is we want to solve our equation. And then this is critical, you want to check the restrictions, which means that you're really checking the domain. Because if you look at a problem and if it results in an answer that is not allowed because of the restriction on the denominator, then you have to make sure you get rid of that as one of our solutions. In fact, let's go ahead and try a problem. This one's going to be a little more complicated. So we want to create our LCD here. And our LCD in this case is we take each factor. This x minus 2 is as a group is a factor. Remember, it's not just the x and not just the 2 because there's a minus there. We treat it entirely as a factor, a binomial x minus 2. No denominator here. So on this one, we take the 6 as for our least common denominator. Now we're going to go ahead and multiply by that LCD on both sides and distribute it. So I'm going to multiply it by every term. So I'm going to list it right above each one of these. I'll do it in a different color so we can see it. But what you want to do is take it and multiply this one by x minus 2 times 6, and this one by x minus 2 times 6, and this one by x minus 2 times 6. Now when we do that, notice this x minus 2 and this x minus 2, top and bottom, since it's being multiplied, it's a factor, it can be canceled out, so I just get 5 times 6 is 30. Here, there's nothing to cancel, so I just have 2 times the 6 is 12. I'm going to distribute it through to the x minus 2. That's going to be a 12x minus 24. So 2 times 6 is 12, times the x minus 2 gives me 12x minus 24. Here, the 6 cancels with the 6, leaves me with the 17 distributing through, 17x minus 34. Now I go ahead and I simplify and solve both of these sides. We reduced out of the denominators. The point is, if you get to this step and there's still a denominator, then we didn't do multiplying by the LCD properly, so we got rid of the denominators. Let's combine. I'm going to subtract 12x from both sides and make this a 5x. 30 minus the 24 is going to give me just a 6 over here. I'm going to add 34 to both sides. And I'm going to get this side to be a 40. And then I'm going to divide both sides by 5, and I get x equal to 8. Now, it's critical to check your restrictions on your domain. Look at the original denominators. You're not allowed to, on this one, the restriction is that x cannot equal 2. So because of that, we're okay with this answer. So 8 is our answer for this one. All right, let's do a few more. The first step on doing this is we want to decide on what our least common denominator is. Well, to do that, I need to factor this one to get what the common factors are. So this one's going to be, when I factor it into x plus 5 and x plus 3. That gives me 5 times 3 is 15, 5 plus 3 is 8. That gives me my factorization. So for my least common denominator, I'll list it over here, I got to take the x plus 5 as a factor. I already took the x plus 5. If there's an exponent on it, I take the largest exponent, but in this case there's no exponent. I got to take the x plus 3. I already took the x plus 3 here from this one, so it's already taken. So there's my least common denominator. Now here it's not a bad idea to right away state what your restrictions are so you don't forget. This is what our domain is. Our domain says that x cannot equal -5, and our domain says that x cannot equal -3 from that least common denominator, from all of these factors in the denominator. All right, let's multiply by that LCD on all these fractions. So x plus 5, x plus 3, x plus 5, x plus 3, and x plus 5, x plus 3. So both sides get multiplied. It gets distributed to both terms on this side. Notice the x plus 5's here cancel. I'm left with 2x times x plus 3 minus, over here I'm going to have this trinomial, x squared minus x minus 10. And notice the x plus 5 cancels with the x plus 5, the x plus 3 with the x plus 3, so they're both gone. I'm just left with that numerator. I put it in parentheses so I remember to distribute through the negative. Then on this one, the x plus 3's cancel out, so I'm left with 3 times x plus 5. Now let's simplify both sides and solve. I'm going to have 2x times x gives me 2x squared. 2x times 3 is 6x. Minus x squared plus x plus 10 equals, multiply through this, I get 3x plus 15. Okay, now for solving this part, I go ahead and I combine like terms. 2x squared minus x squared is just going to be a 1x squared. 6x plus x gives me 7x. And then over here, I still have my plus 10 equals 3x plus 15. Now, when we have a quadratic, our goal is to get 0 on one side and factor and solve. So I'm going to go ahead and subtract 3x from both sides. So it's going to be 4x here. Subtract 15 from both sides, so I get minus 5. This is a quadratic. You can solve it by either the quadratic formula, or in this case, factoring will be a little quicker. Two numbers that multiply together give me negative 5 and add together to give me 4. That's going to be x minus 5, plus 5, and then x minus 1 for my two answers. When I set each of these equal to 0, x plus 5 equals 0, I get x equals negative 5. I take x minus 1 equal to 0, I get x equal to 1. I look back at my restrictions on the domain and notice negative 5 isn't allowed because in this original denominator, in this one and that one, it would give me 0, and that's not allowed in that fraction. So this is not allowed. My answer is just a 1 for that one. All right, let's try one more example. Okay, now for this problem, I'd like you to pause the video. I'd like you to try this one. See if you can factor this one. Come up with your least common denominator. Try multiplying on both sides, solving the equation. See what you get. Make sure you check your answers, and then we'll come back and do it together. Now that you've tried that, let's go ahead and give this a try. First of all, if I factor this denominator here, what I get is I want two numbers that multiply together to give me negative 10 and add together to give me negative 3. That would be a minus 5 and a plus 2. Now, when I look at that from my least common denominator, here, I'm going to take the x plus 2. I'm going to take the x minus 5. I took the x minus 5, and there's no exponents to compare, so I don't have to take the greatest. I've got the x plus 2, so that's my LCD. My restrictions on the domain, if you look at this, I cannot have negative 2, and I can't have 5 be answers. Either one of those would give me zeros in these denominators, not allowed. So let's go ahead and multiply by that LCD on both sides. So I'm going to take that. I'm going to multiply by every term over here as I distribute it through. So x plus 2 times x minus 5. Here I'm going to take it and multiply x plus 2, x minus 5. I'm going to multiply it by this one also, plus 2, x minus 5. We're going to go ahead and multiply in this term. Notice the x plus 2's reduce out. They equal 1. So I just get x times x minus 5. Here the x minus 5's reduce out. And so I'm going to just get the 7 times the x plus 2. And over here, let's go ahead and show that reduced out. Both the x plus 2 reduces and the x minus 5 reduces. So all I'm left with here is my 14 in the numerator. Now, once I get it here, if you don't get to this step, remember, and have no denominators, then we need to start again, because the whole purpose of multiplying by the LCD was to eliminate those denominators. Now we can check our solution, find out what this solves to, and then check it with the restrictions. Let's solve. So we get x squared minus 5x plus 7x plus 14 equals 14. Let's go ahead and solve this. We go ahead and simplify, so we get x squared plus 2x. I'm going to subtract 14 from both sides. I get that equal to 0 then. I'm going to factor out my common factor of an x, so x times x plus 2 equals 0. Set each factor equal to 0, x equals 0, x plus 2 equals 0, so x equals negative 2. I get my answers, I check them against the restrictions. Looks like that negative 2 is a problem, so I don't keep that one, I just keep the 0 as an answer. So that's my solution. So to do these, again, the simplified steps here is if you find your least common denominator, multiply it on both sides to reduce out the fraction denominators in our rational expressions. Solve your equation and then check your answers against the restrictions on the domain. You'll get your solutions to your rational equations.